My name is John Orton. I'm a student at JTech, and today we're going to talk about using a DVOM, basic circuits, and some of the problems you might encounter. So here we have our first simple circuit consisting of two light bulbs, a switch, a source, and a ground. Here it is in action with the source, our two loads, our switch, and our ground. I'll do some measurements. Here we have our total system voltage. Our voltage through our first load. Voltage consumed through our second load with the switch in the home position. Here's our voltage drop through our first load. And here's our voltage drop through our second load. Next to the home test. As you can see, we got the system isolated and the power off. And this is checking the ohms through the over here we can check the ohms through the switch. Right now it's off, so it's OL. Switch it on. It should be very low reading. Now I'm going to check the amperage draw. So we got our meter in series on the ground side. It tells us that we're at 1.13 amps. Here we have our second circuit I made. It's got the lamp in it, or to the resistor, it's 100 ohms, to the switch, and then the ground. Our voltage drop through our lamp is about 4 volts. And over here on the resistor, so about 9.5 with the 100 ohm resistor. You see how the light's dim now. Now we do the 200 ohm resistor. As you can see, the voltage drop has lowered even more to about 1.8 volts. And almost 12 volts being pulled by that resistor. The third circuit has two lamps in parallel. So if up here, you can see our voltage drop across the first lamp. That's the full voltage, 13.6.
Can I move your stuff a bit so I can plug this in this outlet?
Across the second one, it's the same. This voltage in a parallel circuit is the same. If we look at the amp draw across the parallel circuit, we notice that it's much higher than it was in the series circuit. For my last setup, I got a relay set up with 4 bulbs, 2 bulbs in parallel with each other. Each set on normally closed or normally open side of the relay. You can see our ground side control switch is here. And when it activates the relay, it's switching between those normally open, normally closed contacts to provide power to the different set of lights. Okay, now we got a parallel circuit with 4 bulbs. We're talking about short to ground. If the short to ground came after the loads, it's over here, they'll just light up. If it came from one load, that load won't light up. But I see the others will. Now it's a direct short to ground from the power side. It's going to end up the current a lot, overheating and blowing the fuse. An open is just basically a break in the wire switch. When it's off is an open position. So you can see with an open, doesn't work if it's affecting the whole circuit. The parallel circuit, if one of them was open, usually just that one light goes out. If there was series and it was open, all the lights would go out. A blown bulb can also be seen as an open too, as the path is incomplete. And for high resistance, we want to use this 300 ohm resistor to just simulate what that'll look like. So it'd be like a background in this case, super corroded. And with this much resistance, we've got very little to no light coming through. And that about wraps it up. Just remember that when you're finding amperage, you need to be in series with your circuit. When you're finding voltage, you need to be in parallel. And when you're finding ohms, you need to have the item you're looking for the ohms isolated and separate.